Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps of the world's best companies as quickly as possible. So I've spent quite a bit of time in the past few lessons talking about classes because they're so integral to .NET. In fact, just about everything you do in .NET somehow involves a class. And we talked about how the .NET Framework class library is really just a collection of classes that contains functionality you can use, but you don't have to write yourself. Microsoft has already spent tens of thousands of man-hours writing code that you can just borrow by merely referencing the class name that you need and then calling the method associated with that class. And that was really the purpose of learning more about inheritance in the previous lesson. We said that Microsoft has created the classes in such a way that there's this rich inheritance hierarchy. It's a means of specializing and extending base classes. In some cases, it's beneficial to Microsoft because this allows for code reuse and ease of maintenance. In other cases, it's beneficial to end users like you and I because we can leverage knowledge about, for example, how streams work to all types of specialized stream classes. Stream classes for working with file data, network data, database data, and a lot more. And so we can leverage what we already know about streams and work with all kinds of different streams because they all inherit from a single base class, system.io.stream, I think it was. So the .NET Framework base class library is composed of a rich inheritance hierarchy between classes. But because I really want you to understand how the .NET Framework base class library was put together and how it works, and most of all, how you can get the most out of it, I want to talk about one final topic related to all of this, and that is to better understand how the code is organized and how to access some code that isn't just added to your project by default. So we're going to talk about namespaces. We're going to talk about assemblies, and we're going to talk about adding references to external assemblies using the tools in the Visual Studio IDE. So let's start by creating a new project, and we're going to call this Namespaces. Let's spell that right. Namespaces and referencing assemblies. All right. And so first of all, within the .NET Framework base class library, all the classes are organized into namespaces. What is a namespace? I mean, we've seen how we were using the import statement and I identified that as a namespace, but what really is a namespace? What's its purpose? Well, think of a namespace as a last name for classes. So, for example, my first name is Bob, but there are literally hundreds, if not thousands of Bobs just in the little town that I live in. If somebody were to say, Bob likes coffee, you might ask, okay, which Bob are you talking about? There's like a billion Bobs in the world. And if they reply with my full name, they're like, oh, no, I'm sorry, Robert Theron Tabor likes coffee. Well, now you should have a pretty good idea who they're talking about. I mean, I'm pretty sure that my middle name and my last name combined are pretty unique. So that might only identify one person in the entire world. The same is true with classes in the .NET Framework class library. With tens of thousands of classes in the library, it's possible that a single name of a class is actually shared by several different classes. However, by using the namespace of the class, it removes the ambiguity. While you might know which class you intended to use, when you go to compile your source code, the Visual Basic Compiler, as it tries to make sense of your code, as it tries to create an executable file, an assembly, it tries to resolve the reference to each class that you reference in your code. And we saw that a few lessons ago whenever we typed in the word stream reader in the IDE, it complained, it said, I have no idea, I don't recognize that class name. Where did you get that from? So when the compiler is confused, it stops immediately. It refuses to continue on the process of compilation until you explain further what you meant, and that is called a compilation error. So when I wanted to reference the stream reader class, I had a couple of different options. The option I chose was to use an import statement, but I could have done something like this instead. Dim my stream reader as new system.io.stream reader, and then I can give it some file name .txt. Okay. So you can see here that I'm using the full name of the class name itself, as well as its namespace. So first of all, this system part is a top-level namespace that many other namespaces and classes belong to in the .NET Framework class library. Secondly, the IO namespace, the sub namespace, I guess you could call it. I don't think it's usually called that, but it contains namespaces and classes that deal with IO, in and out, or rather getting data into the application and sending data out of the application. And so then third is the actual class name, stream reader. So this system.io namespace, when you combine it together, first of all, it shows you that namespaces can and often do contain other namespaces. So the IO namespace is actually part of the system namespace, kind of a sub namespace. Again, I'm not sure if that's the right terminology, but you can use any number of additional namespaces, so we could continue to build on to a third namespace, a fourth namespace, and so on, as deep as we'd like to create it. However, the developers of the .NET Framework class library realized that too deep of a nesting structure with the namespaces would add too much complexity. So I guess the takeaway from this is, first of all, most of the namespaces in the .NET Framework class library are either they either have two components or possibly three, but generally never more than three. And so, again, the takeaway here is that if you're ever in a position to create your own libraries and you want to use namespaces to disambiguate the class names, then you probably should strive to use as few namespace, sub-namespaces, I guess you could say, as necessary to help those who are consuming your code find what they need. So, again, as we take a look at this line of code, you might be asking if you always have to do this sort of thing. We said there were two ways to resolve that stream reader issue. The first was to use the entire namespace every time, but that's a lot of typing and it's unnecessary. The other option is to use an import statement to shorten the amount of code that we really have to write from this point on. So an import statement provides access to all the namespaces and classes that belong inside of that namespace, so that you don't have to type it all out from that point on. So you're telling the compiler, hey, I'm importing these namespaces. Look here at the top of the file. It'll apply to everything inside of this file. So before you complain and you say, I don't recognize one of the class names, please check these namespaces first to ensure that the class that I'm referencing in my code belongs to one of them. If it doesn't belong in there, then go ahead and complain, okay? So as it turns out, Visual Basic hides all of the imported or the default imported namespaces from you to reduce the code clutter. But you can access them. You can see which ones are added by default for a given project type, like the console project type that we've been working with, by looking in the Solution Explorer. Let's pin this down for a moment. And if you take a look at this My Project icon and double click it, it'll open up the property pages for the project. And there's all sorts of things in here related to, I guess you could call metadata, things about the project that may or may not be compiled into the final assembly or might affect compilation. Now what we want to do is take a look at the References tab here, and you can see that, first of all, there are actual files that are referenced. So this is where, these are the files where basically the .NET Framework class library is implemented. And inside of those files, you'll see a number of namespaces that own classes. So if we were to look here near to the bottom of this list, these are the namespaces that are imported by default, the ones that have little check marks next to them. Now here are other namespaces that are available from this list of assemblies here that have been referenced, but they have not been imported. So if we were to scroll down and take a look, you can see that the system.io namespace probably lives inside of either, I'm guessing, this system.dll or system.core.dll, or possibly one of these others, but I think it's probably one of those two. But it has not been imported by default. If I were to select and click this and put a check mark next to it and then save, and now I could get rid of this system.io part and it would work just fine. We'd be able to compile our application. Let's actually build it. And it would succeed. Why? Because Stream Reader, the class name, can be found through this imported namespace. But if I were to deselect it And you can see immediately the IDE complains with the blue squiggly line, and it gives us some options, and we've already noted how we can resolve this by using an import statement. So typically I don't type import statements. Typically I just click the little option to add that line of code, import system.io. Notice when I do that, the blue squiggly line disappears. Again, I can build the solution. It succeeded in building, and so all is well. Now let me remove this line of code just to show you one other thing. If I was on this line of code and I typed it out, I knew I needed the stream reader, and then I realized, oh, I need to add an import statement. Typically what most developers do is hold down the control key and then the period on the keyboard, and that will pop open that little dialog without having to remove my hands from the keyboard. I can just use the down arrows to select the import system.io, and then I can be on my merry way, continuing to type, and I can move on from there, for example. Okay, so that control period is a way to add an import statement without having to use the mouse, hover your mouse cursor over that little red dash that opens up the little red X dialog for the contextual menu that popped open. Okay, so let me just say this as well. Occasionally you'll attempt to use a class in the framework class library, but you'll get an error that says something about there being ambiguity. The reason is that you might have two import statements, or you might, through the use of the references tab in your property pages, you might be referencing two namespaces that have the same class name inside of them, okay? And you just happen to have imported both of them into your project. So when that happens, you merely have to type out some or all of the namespace before the class name. It's a simple way to resolve it. It just means that you just so happen to use two import statements or have imported two namespaces with this exact class name in it, and it still didn't know which one you meant. So we're going to type out the full system.io.streamreader in this case. Okay, doesn't happen very often, so don't worry about that, but just in case you ever see that. Okay, so one last tip. If you need to look for help on a given class name or a method name, sometimes in the search, whether you use Bing or Google or whatever the case might be, you might want to add the entire namespace. Otherwise, you might be looking at the help for a version of the class that belongs to another namespace. So if I was interested in the system.io.streamreader class, I would type in system.io.streamreader in search to find the MSDN article for that specific class. Not taking the chance that there's a stream reader defined somewhere else in the .NET Framework class library with the same name stream reader, and then I'm looking at the methods and they're not lining up with what I'm trying to work with. It happens occasionally, again, not often, occasionally. All right, so before we close the discussion of namespaces, let me point out a couple of things. First of all, every class that you create on your own, when we created the car class, for example, it will be contained in a default namespace. The default namespace will be the name of your project. And for simple applications, you will never need to modify or add additional namespaces. Secondly, if you don't use the project name as the default namespace, you can set it in the project properties. So if I go back up to the application tab of the project properties, you can see that the root namespace is currently set to the project name, namespaces and referencing assemblies, but I could change that to something like Tabor, for example, okay? And then from that point on, any of my classes, for example, if I add a car class, let's go ahead and do that. I'm going to go ahead and add a new class called car. And I'll just create one property, public property, make as string. All right, and now if I want to use that, I can reference it like Tabor dot, and then you can see Tabor.car. All right, and of course we're not doing anything with this. I'd have to call, you know, a method, or create a new instance of car, but you get the idea. So that's the second thing. If you want to change the root namespace, you change it in the property pages on the application tab under root namespace. Otherwise, it'll be the name of the project. All right. And then third, likewise, you can create new namespaces for your own code using the namespace end namespace. So if I were to do this, for example, let me do a namespace Theron, all right, and it automatically created the end namespace, and I'll paste that in like so. All right, now I should be able to reference the car class like follows. So dim my car as new tabor.theron.car. All right, see how that works? I was able to create additional sub namespaces by using the namespace end namespace structure. All right. So again, the technique is very simple. Now the reasons why you might choose to do this, why you might choose to even introduce namespaces into your application architecture is a little more advanced. Again, if you set out to build large software applications and you needed to organize your code into namespaces or organize your code in such a way that there won't be collisions between class names, then this will become more important to you. If not, don't worry about it. Again, advanced concept, you don't need it until you build bigger applications. All right. So let's move on. As we learned a moment ago, in an effort to keep the .NET Framework class library manageable, the creators split up the .NET Framework into a number of classes, or rather, a number of individual files. So there are tens of thousands of classes of code, and they split them up into a few dozen files. Why did they split them up? Well, if you had to load up one monstrous file with the entire .NET Framework class library, in most of which you'll never use, into memory, each and every time that you ran a .NET application, it would take up the entire computer's memory and be extremely slow. So instead, they put related functionality across many different namespaces into individual assemblies. And you can see them listed here by default, the ones that have been added to this project type, the console project. So when you create a new project, the template for that project includes references to several core assemblies by default. Of course, we've already been talking about the console window project type. If I wanted to create a WPF, or rather Windows Presentation Foundation application, you know, with a little bar on the top, and I can resize the windows, and I can actually work on the Windows desktop and create a graphical user interface using this portion of the .NET Framework class library called Windows Presentation Foundation that allows me to create those windows and the buttons and the text boxes and so forth. Then I would choose, when I go File, New Project, I would choose a WPF application template. And that template will contain and add references to several important assemblies required to build WPF applications. So again, just wanted to point out that these are the default assemblies that are referenced by the Visual Basic Console application template. So what do you suppose happens whenever you realize that you need a part of the .NET Framework class library that hasn't already been added? It's not part of this list of assemblies that have been referenced by default. Well, then you have to add a reference to that assembly. In fact, this is not only true for assemblies that are created by Microsoft and are part of the .NET Framework class library, but it's true of third-party assemblies that you want to use in applications, whether they're commercial products that you've purchased, open source libraries, or even libraries of business rules that are specific to your company or organization. You have to first add a reference to the assembly in the project so that when you reference the namespace and the class names, it will know which files to look in for the actual code implementation. So since I want to keep this as simple as possible, I've created a super simple library of my own called Tabor. In fact, to make sure this works, I probably should remove some things here. Let me go ahead and switch this back to the root namespace. Just leave it what it was by default. I'm going to comment out everything here just because I don't want there to be any conflicts or any problems. All right. And then I want to go back to the references dialog, and I want to actually add a reference to an assembly that I created, and it's available for download wherever you are currently streaming this video or from wherever you originally downloaded the video from. I unzipped that file into my documents directory, and there's a tabor.dll that I want to add a reference to in my project so I can use some of its functionality. So I'm going to click the Add button here below this list of assemblies that have been referenced in my project, and this will pop open the Reference Manager. And what I want to do, and you can see that there are just a bunch of files. Some of them have already been added, right? Like system and system.core, system.data. They've already been added, but there are just literally dozens of files, and some of these are for things like ASP.NET or creating Windows applications or working with data and so forth. All right, and we're going to ignore almost all of these. Instead, we're going to go to the Browse tab here on the left-hand side, and I'm going to click the Browse button. And I'm going to go to my Documents directory where I've unzipped Lesson 18 source code. And there should be a tabor.dll file in that directory after you've unzipped it. I'll click Add. And then I'm going to click OK to add that reference to that assembly. So now you should see that we have added a reference to the tabor.dll file. Furthermore, if we were to scroll through the imported namespaces, there's now this Tabor namespace that's available. And that Tabor namespace includes a class called Bob. So let me save what I've done so far. I'm going to go to the module1.vb here, and I'm actually going to comment all this out. Let's comment that out. All right. And here, we're going to write the following code. So dim Bob as new Bob. All right, so the first thing that might look odd is that I'm using the name Bob, capital B-O-B, as the identifier for a new instance of the Bob class. And that's completely acceptable. The compiler can figure this out. Typically, I would do something like my Bob, but I just wanted to show you that this was possible, all right? And so now we can work with Bob from that point on. But notice that Bob is not defined, so if I can import the Tabor namespace, and now it seems to locate everything just fine. And what I'll do next is I'm going to dim HTML as string equals bob.lookup, and what this method will do is it'll allow you to pass in any URL, and it will go out to that URL on the internet, and it will download the HTML for that given web page or that website. So I'm going to give it the home page for my website, http://www.learnvisualstudio.net. And then I'm going to do a console.writeLine with the HTML that we've returned back from the lookup method of the Bob class in the Tabor namespace in the tabor.dll assembly, and then console.readLine, like so. Now let's run it to see if it works. And after a second, it sure does. It brings back a bunch of HTML from my website. Awesome. And I also want to point out that while we reference that assembly from the Documents Lesson 18 subdirectory, once I create a debug or release version of my application, it will be found in the bin/debug or bin/release folder. So let's go to Projects, Namespaces and Referencing Assemblies. We'll go in the Project folder, in the Bin folder, in the Debug folder, and now you can see that it's copied that assembly that it will need for this application to run. It copies it into this folder so that we can package the whole thing up and distribute it onto somebody else's computer, knowing that this executable file relies on the existence of tabor.dll. And you might be wondering, okay, well that's cool, but where are all the .NET Framework assemblies? Well, that's why that whoever uses your .NET your .NET application, whether you build it in Visual Basic or C# or C++ or F#, whatever the case might be, when they have to install the .NET Framework runtime on their computer, and it will contain all the assemblies. And you can just rely on those base assemblies being part of the .NET Framework class library that are already installed on everybody's computer, everybody's Windows computer, and your application will work, will reference the assemblies that are already installed on their computer, and then any additional assemblies that are needed by your application will just be copied over in the same folder as your executable, and there's a number of different deployment strategies, but that's the most basic one, okay? All right, so let's go ahead and recap what we talked about in this lesson. We learned how classes are organized into namespaces to help disambiguate class names, or rather, to help avoid name collisions between two classes that are named exactly the same thing. We talked about the import statement that allows us to shorten the full name of a class by telling the compiler that it should first attempt to resolve all class names against those namespaces that we've added into the import section at the very top of our code file. I also demonstrated how to use the IDE to help find namespaces for classes that we want to use within our application. We also looked at the control period technique, or the drop-down contextual menu to add import statements. We looked at how we're able to make changes inside of the properties for a given project on the References tab. We talked about the topic of how code is packaged into assemblies, and that when you create a new project from a template, part of the job of the template is to add references to commonly used assemblies. The .NET Framework class library is so large that it wouldn't make sense to load the whole thing up and to reference every part of it every time that we needed to run our application when we only need a little part of it. So that's why they split it up in all these different assemblies. Additionally, many companies have created their own libraries of code that you might need to use if you go to work for them, and they encapsulate the business logic that are necessary to work in a given area of the business. Also, there are third-party vendors as well as open source projects that provide libraries that you might want to use within your application. In these cases, you have to add a reference to the assembly that contains the given library of code that you want to utilize. Okay, so up next, we're going to talk about those mysterious private and public keywords that we've seen, I've referenced, but we've largely ignored up until now. So we'll discuss that in the next lesson. We'll see you there. Thank you.